If you have been keeping up with my recent videos, you might remember this website from a previous project where we rebuilt the full screen menu inspired by it. While exploring this website more, I came across this really impressive carousel slider. At first, I skipped it because honestly it looked a bit complex, especially the timeline and how it continuously moves in a unique layout pattern. But over the weekend, I decided to give it a shot and rebuild this slider using JavaScript and GSAP. It took me around 3 to 4 hours, but I managed to create a very close replica which is responsive as well. I must say it was quite interesting to figure out the logic behind it. In today's video, we'll focus on managing the slider through clicks, but if you want, you can definitely leverage the function we'll be creating to automate it after a set duration. Make sure you leave a like and subscribe if you haven't yet. Alright, let's dive into the code now. Let's begin by setting up a navigation bar and a footer. I'll include a few links and insert some placeholder text within them. Now let's focus on the main component, the slider. We'll start by creating one slide with an image inside. I'll replicate this slide 4 more times, assigning unique IDs to each and updating the image sources accordingly. Next up, we'll put together the timeline. To keep things straightforward, we'll use a paragraph element for this. I'll add 8 time markers. We'll manage their looping with JavaScript. That wraps up our HTML setup. Let's move on to styling now. Let's start by resetting some default styles. I'll set the margin and padding to 0 and apply box sizing border box to everything. For the HTML and body, I'm setting the width and height to fill the viewport and applying a black background color. I'll also set overflow to hidden. For links and paragraphs, we'll remove the underline, set a light gray color and define the font. Now let's style the nav and footer. Both will be fixed at the top and bottom of the page respectively and span the full width. They'll contain evenly spaced items and stay above other content with a higher Z index. In this slider, I'll position it absolutely to cover the entire screen and hide any overflow. To add a dark overlay, I'll use a pseudo element with a semi-transparent black background. Each slide will also be positioned absolutely, allowing us to layer them directly on top of each other. Images will fill their slides, maintaining their aspect ratio without distortion. As set, we'll change on transformations to optimize performance during animations. Finally, for the timeline on the right, it's vertically centered and slightly extends beyond the viewport width. This extra width is a clever trick to hide the first flex item, just off the left side of the screen. I'm using flexbox here to space out the time markers evenly. These are styled distinctively with a larger white font and a smaller uppercase superscript. As the screen size decreases, I have adjusted the timeline width to ensure it remains visible and functional. That's all for the CSS. Now let's dive into the JavaScript to make our slider and timeline dynamic. First up, we register the GSAP plugin for custom easing. This will allow us to create smooth easing effect. As soon as our page loads, we'll kick things off by setting up our slider functionality. I'll start by grabbing the slider element and all of its child slide elements using the query selector and query selector all methods respectively. We'll also set up a variable named animating to false, which we'll use later to control when our animations can run to avoid glitches. Next, I'll define a variable duration and set it to 1.5 seconds. Now for each slide except the first one, I apply a CSS clip path that effectively hides them from view. This clip path uses a polygon shape that's collapsed to a single point, making them invisible on the page. The first slide doesn't get this treatment because it's the one we want to show when the page loads. Now let's handle the appearance of our timeline counters. To do this, I have created a function called initializeFlexValues. This function will set up the initial visual state of each counter in the timeline based on their position. First, we grab the timeline element and all its paragraph elements, which represent our counters. I want the first few counters to be visible and decrease in size progressively from the first to the fifth. To achieve this, I set the FlexGrow property, which controls how much space each counter will take relative to the others. And I have set their width to max content so they adjust based on the content size. For any counters beyond the fifth, I set their FlexGrow to 0 and their width to 0 pixels, effectively hiding them from the view. This helps us maintain the focus only on the visible parts of the timeline. Once we define this function, we call this function to apply the styles as soon as the script runs. Next, let's talk about how we keep our dynamic timeline flowing smoothly with the append new counters function. This function plays a crucial role in refreshing the timeline as counters transition off screen. First, we grab the timeline element and convert its counter elements into an array for easier manipulation. We identify the index of the first visible counter by checking for a class named first. This helps us determine which counters have moved out of the view. Once we have the index, we loop through all counters up to this first visible one and remove them. This step is essential to prevent the buildup of unused elements in the DOM, which could slow down the page over time. After clearing the old counters, we add new counters to maintain a continuous flow. Each new counter starts with 0 growth and no width, making them initially invisible. This approach ensures that our timeline is not only continuously updated but also optimized for performance. Now let's dive into the handle slider function, which is the core of our animation logic for the carousel slider. This function handles the transition of slides and updates the timeline counters accordingly. First, we check if an animation is already in progress by evaluating the animating variable. If true, we simply return to avoid overlapping animations. We then refresh our slides list from the DOM to ensure we have the most up-to-date collection. We grab the first slide and its image, as these will be the starting point of our animation. If there is more than one slide, we proceed with the next animation. We move the second slide's image 250 pixels to the right initially to set it up for the entrance animation. Using GSAP, we animate this image to slide to its original position, giving it a dynamic entrance effect. Simultaneously, we animate the first slide's image to slide out of the view to the left. Finally, we update the clip path of the second slide to make it fully visible. After managing the slides, we shift our focus to the timeline. If the last visible counter is marked as 7 PM, we trigger the append new counters function to recycle and update our counters. Lastly, we clean up by removing the first and last class tags from all counters, preparing them for the next cycle. We also set flags and attributes as needed to maintain our cyclic animation logic. We then handle the dynamic updating of the timeline counters. This is crucial for creating a looping effect where the counters transition smoothly. We begin by cycling through each counter from the end to the beginning. except for the very first one. This reverse loop allows us to update the flex grow and width properties based on the preceding counter, creating a cascading effect. This segment of code not only shifts the visual growth of each counter but also adjusts their width dynamically. If a counter's flex grows was set to 5 by the previous counter, it becomes the first visible counter receiving the first class. Conversely, if its growth was the smallest and no other has been assigned as the first, it gets the last class. Finally, we handle the very first counter by setting its flex grow to the last counter's previous flex grow. This helps maintain continuity in our loop. With this approach, each counter smoothly transitions into its new state, ensuring the timeline is always lively and engaging. To activate the slider function, we listen for clicks on the document, triggering the handle slider each time. This setup ensures our carousel not only displays beautiful transitions, but also interacts dynamically with the user input, providing a seamless experience. Hope you found the video helpful. See you in the next one.